Assalamualaikum warahmatullahi wabarakatuh, and hello to all my friends and to our lovely lecturer Dr. Mahfuzah Mukhtar as our ECC 3003 lecturer for this semester. Today, I, Muhammad Hazrin bin Hadran, with my team members Muhammad Aizat bin Abdul Wahid and Abdul Majid Husam Hussein will making a video about our second assignment about applications of Fourier transform. This video will show to you how we can appreciate the topic that we already learned in our class about the topic of Fourier transform and how we can relate this kind of topic with our daily activities. To ensure our second assignment are nicely done, I and my team members already arranged several important meetings to discuss about the applications of Fourier transform. We have done several meetings and already done continuous discussions using almost social media like WhatsApp, just to share any informations or any new knowledge that we can present in this video. As you can see from the video, almost every day we change an idea about how we can improve or how we can relate this kind of applications with our living activities. I believe most of us, including me, already apply the basic concept of the Fourier transform in our daily activities. Example like me, I use picture editor like Adobe Photoshop, Lightroom, and also audio editor like After Effects and Movie Maker, just to improve the quality of the audio and the quality of the picture. So, how can we improve the quality of image or the quality of the audio? Example, to improve the quality of audio, we can remove unwanted noise and unwanted component. We can use filter to increase or to decrease the output of the audio just to make it more pleasant. For the picture or image, we can improve low quality image with a bad sharpness or noise by removing the blur or the noise from the image. As a result, we can produce a high quality image using the concept of Fourier transform. For further explanations, I will ask my team members, Aizat and Majid, will explain furthermore how this image digital filter and audio digital filter can be related with the concept of Fourier transform.
Alright guys, image filter is very complicated issue, but image filter for the transform for the Fourier transform can do processing of the image such as brightness, sharpness, noise, and a more different method relating to the image processing. Okay, now normally the image can be represented in another way. It's called frequency domain. This frequency domain is defined, or each image channel is represented in terms of the sine form, in a sine form. Let's give a fast example, simple example for this, such as this one. Here is the image, and it has been represented by the sine wave. But as you see here, this is the ideal sine wave. So this image has been represented by the sine wave transform. Okay, so we have the MATLAB here. I changed a little bit from the code in the MATLAB because it was not working previously. So I changed some of the lines. So and at the end it works. So this is the representations of the Fourier transform in the MATLAB, and we can see the result throughout the figures. So this is the figure 1, how the original image can be changed to the noise, and then the gray image into the noise gray image. And then we have a figure 2, figure 3. This is the impulse response to the ID Hamming. Figure 4. This is the 3D and the 2D Hamming. And the figure number 5 is the noise image, and the noise image after filtering, as you see. This is after filtering, as you see here. And then figure 6, this is the convolution kernel, the different here. And also figure 7, the gray image and the representation, and also the gray image after the convolution and the representation here. Also we have the same thing, different method of image processing. So this is the image filter in very short form. It can be also represented by the spatial domain, but we're not going to include this in this video because it takes longer time to demonstrate that. Thank you so much. I am Majid.
Thank you, Mr. Majid, for the explanations about the image digital filter. Next, I will ask Mr. Aizat to explain the component of audio digital filter.
This is audio filter system, okay, where we use the operation amplifier to amplify the input. Okay, as we know, 10K R1 and 10K for R2. Amplify equal to 1 plus 10K over 10K, so 1 plus 1 equal to 2, so amplify will be twice. Okay, this is filters and the switch. So this switch you can use to choose which one filter we want to use. Okay, for port C is to see the output from the amplifier, and A to use to show the input, and B to show the output after filtered. Okay, let's take a look to the basic filter. On the left hand side is low filter, and the right hand side is high pass filter. So for the low pass filter, load the lower C for the graph frequency and block the higher frequency. However, for the high pass filter is block the lower frequency and allow the higher frequency. Okay, this filter will the low pass filter will allow the 5 Hz frequency and below, and for the high pass filter allow the 5 Hz frequency and above. So let's check. Okay, we choose one as frequency lower than 5, right? So okay, for the low pass filter will allow, and the high pass will block. Okay, let's change to 10. 10 is higher than 5. So for the high pass filter will allow the frequency. However, for the low pass filter will block. Alright. Okay, the conclusion is Fourier transform or the Fourier series is convert time domain to the frequency domain. Okay, this is time domain, and then this is the frequency domain.